And please welcome Paul.
Good afternoon. It's very nice to be back in Riga. This is my second time at DevTernity. Today I'm going to be giving a talk on Chaos Engineering 101. Okay, we're going to talk about a little bit of chaos engineering. This is a huge topic that you can get into as much as you want to within your organization, but this is very specific to how you get started today. Okay, my name's Paul Stack. You can find me on the internet, Stack72. I work at a company called Joyent, and we have a cloud called Triton. I absolutely love infrastructure. Before this, I was part of the team that was building Terraform, so a lot of my demos are going to include Terraform. I apologize. So let's think of distributed systems today. Okay, we have maybe 60 APIs that talk to each other. We have an API that talks to both 2-3 other APIs, and then it also talks to databases, document stores, it talks to S3, it talks all these different things, okay? Our systems are becoming much more complicated. I've got really small ears, so this keeps falling off, so I apologize if you keep losing me. Our systems are becoming extremely complicated, okay? We have so many moving parts in these systems, and it's much because of the fact that we have disconnected and remote teams. Okay, so I know, for example, a lot of companies in the US who have engineering teams in Latvia, Lithuania, Ukraine, Estonia, and so on and so forth. So it's very, very difficult on the overlap of time between this part of Europe and the west coast of the US, because it's 10 hours plus or minus. So things are being built in complete isolation from each other. Now, another big factor is complete language stacks. I worked at a company that may or may not have made the right decision by telling developers that they could go and build whatever applications they were building in whatever languages they wanted. Okay. Now, of course, you give a developer that amount of freedom, and it's open season. And I remember one of the APIs being built in Clojure, and the developer who built it in Clojure had never written anything in Clojure before. So having to integrate with all these systems becomes an absolute nightmare. And unless you actually have an overall idea of what talks to each other, then it becomes very difficult. Now, this image right here is from a product called AppDynamics. AppDynamics is like an APM, a monitoring tool, and what it actually does is it will plot all the different pieces of your system when you tag them correctly, and it'll show you all the different connections between each other. So I just went to an article on TechCrunch and took this image just so that you could actually see how many moving parts there are in a distributed system. Testing can happen anywhere along this way, okay? We're mostly looking at software right here, but of course, every piece of software here runs on hardware. And not only can we have software failures, but we're now starting to understand more in IT that our hardware isn't always reliable. And if you believe that it is reliable, please rethink that. Throughout my career, I've always been told that I should never test in production. Okay? Now, in the past maybe 2 years, I have realized that that's actually a complete fallacy. Okay? Obviously, test before production as well. That's, you have your pipeline, you test in dev, you test in whatever other environment you have staging, you have QA, whatever, okay? But real testing actually can only happen in production. The reason that is because we never usually have an environment that mimics what our production load is, okay? So, for example, we take 800 million requests a day through our production environment. Do you have enough hardware in your QA environment that will actually mimic that? I'm pretty sure your company won't invest the same level of money in QA as it does in production. Do you have the 100,000 users that are hitting your site at any one time in QA? If you have QAs that have written scripts for that, they're worth their weight in gold, and please treasure them. Please treasure them. Or in the last one, do you have enough network set up in your QA environment that mimics production? Because of all of these questions, and because there are so many moving parts, it becomes extremely difficult to work out how real-world effects happen in our QA and our staging environments. So how do you build a distributed system and scale it at the same time? Okay. So the answer is actually chaos engineering. You can come in, don't worry, I don't mind. There's one here. So the answer is chaos engineering. Now, there's a very simple definition of chaos engineering that was decided by a company called Netflix. I'm pretty sure everyone knows who Netflix are, okay? Anyone in the ops world? You don't know who Netflix are. So Netflix are a content streaming service for video, okay? So like movies and TV shows and so on and so forth. At any one time during peak in the US, they actually own something in the region of 25% of the entire internet traffic in the US because of their CDN. They're an absolutely ginormous company, okay? And they introduced this idea of chaos engineering. And what they say is that chaos engineering is a discipline of experimenting on a distributed system in order to build confidence in the system's capacity and working out if you can actually withstand turbulent conditions, okay? So in a nutshell, chaos my thought process of what I believe chaos engineering is the facilitation of experiments to uncover weaknesses in our system. It's as simple as that, okay? All systems have weaknesses. All systems. If you take one thing away from it today, take away that. Okay? If you believe that your system does not have weaknesses, then one of two things is happening. One, you are the best developer the world has ever seen. Okay? And I'm going to trademark that. Okay? Or number two, you actually have no idea what's going on in production because you have no pane of glass to see what's happening in production. And usually, I'm not going to say always, usually it's number two. I am sure we have some wonderful developers in here, really wonderful developers. But if you don't have enough understanding of what's going on in production, you have no idea what's happening at any given moment. And that is extremely dangerous. So, think of many layers in our system. Okay, many layers. We've got app layer, cache layer, database layer, network layer, hardware layer. We have, obviously, we have operating system layer. We have rack. We have power supply. We have everything, okay? We, as developers, usually care about, I apologize if there's anyone else apart from developers in here. I'll come back to you in a minute. We usually care about app, cache, and database, okay? How many developers usually care about the networking layer? I want to hug you. So, or not many developers care about the operating system. I don't even think many developers will know what type of rack that their hardware lies on because it could be in the cloud, it could be in a data center that their company owns or something. Okay, so we care about a tiny piece of our system, okay? But in order to build the best systems, unfortunately, here's the big realization, we need to be a lot more aware of what's going on. Full stack. This is full stack development. Not JavaScript and back end. I can't rant because this is recorded, so it's fine. But you can inject chaos into any of these layers. Okay, so for example, you can inject network blocking or API blocking into the application layer. Okay, and stop one application talking to another application and see how the system reacts. Okay, you can actually introduce a failure in your cache. So that way your applications will have to bypass your cache and go directly to your database. Does that add extra weight to your database? You can certainly put problems in your database and see how your system applies. And you can have problems in your hardware, you can have problems in your network layer. You can pull the cord in the rack for the power and see how your system responds. Okay? People laugh, but it's true. People do this type of stuff. This is disaster recovery testing, DRT. Many companies have been doing this for a long time. But only when we understand how our system interacts with an external force is when we will know if we've built the best system that we can. So what I mean by that. Developer builds a very nice system. Developer works very closely with a QA, and they test that system. But what do they test? They test what they expect people to do. They test the knowns. Okay? They test the happy path through the system. Maybe they give a little bit of thought process to like an interesting way. Okay? Mr. User comes along or Mrs. User comes along on the front end. They give our system abuse in the ways that we don't even understand. Because, and again, I have to be very careful what I say because it's recorded, users are stupid. Users do not, and I say that in a nice way. I'm jesting when I say that, I promise you, okay? Users work in our systems in the way that they expect them to work, not the way we expect them to work. So only when we can understand external influences from users, again, do we understand how our software works when users are that. Who's worked in a company where their bosses come up to them and said, we've had a complaint from this user saying that they can't log in on this URL, and you're like, does that URL even exist in our system? But it was in an email. Oh, because the marketing team sent out an email that had a link that's been broken for 3.5 years. Okay? I may have regrets about that type of story. But it's true, it happens all the time. It really happens all the time. People can't understand the paths through the system. You can hit the green on the way out, that's fine. Okay, so in order to test what we're doing, there are 4 very simple principles of chaos engineering, okay? 1, we define the steady state. So we need to know at any point in time how our system is performing. If you do not understand how your system is performing, you cannot go any further than this step. You really have to put some thought process into how your system is performing. We'll talk about that in a second, okay? Number 2, we have to understand and hypothesize that at any given time, without external forces, that steady state will continue, okay? A very complicated way of saying, after 24 hours, you should still see the same state that you saw 24 hours ago. Okay, it should be smooth, and we may be seasonal and we may be trending hour on hour, but we should understand what's happening. Number 3, we introduce events that mimic real world events. Okay, now when I say events, what I mean is like network interruptions. I mean hardware failure. I mean disk being full. I mean network latency. All of these different things are events. Okay, if you're in the cloud, machines disappearing because they disappear every day. Number 4, we try and disprove the hypothesis that the steady state will continue. Okay, because if you introduce an event and the steady state disappears, then you have to go, what do I have to do to make sure that doesn't happen the next time it happens in production? What do I have to do to stop that chaos in my system? What do I have to do to stop people having outages based on what's just going on? And this is what chaos engineering is. So we'll talk about monitoring. You really must monitor. I almost swore. I apologize for almost swearing, but I promise you, you have to monitor. It's the only, and I mean the only prerequisite to get started in chaos engineering. To take your first dip into chaos engineering, you must monitor. And there are different types of monitoring, okay? So there's system availability, okay? Does anybody understand the number of 400s versus the number of 500s versus the number of 200s on their applications? That's an actual question. Does anybody? Anybody know the percentage? So a few people, okay? Try and put at least that one metric in place. Try and work out the percentage of failed requests coming into your system, intra-API requests, anything. Just to work out how your system talks and if there's actually anything happening between each other. Number 2, we have system metrics. Okay, system metrics are things like CPU, memory, disk. But of course, just measuring them at any point in time is of no use. Absolutely no use whatsoever. So I get an alert at 4 a.m. and it just says the disk of machine X is full. Okay? That has no context whatsoever. That has real, there we go, it's better. That has no context whatsoever. If the machine X has got a full disk, is that across a week? Is that across a month and no one's actually looked at it? Or is it a case of machine X has had its disk filled in the last 2 hours at a huge growth of usage? That's the type of context we want in system metrics. Number 3, user metrics. If you have a system that has end users, and end users make calls to your customer service or something, you should be able to know on an average day how many users are making calls to your customer services. Okay? On Monday, it's probably a little higher. On Tuesday, it drops, and so on and so forth. Because you will then be able to understand that if you have a huge spike in customer service requests, maybe there's actually a little problem with your system. Maybe. And number 4, the most important thing that most people forget about monitoring is service-specific metrics. Okay. Now, what I mean by that is, again, if you have a system where a user actually signs up to your system, you should know how many a day, on average, people sign up or register to your system, how many people log into your system, how many transactions goes through your system, how many searches happen on an average day go through your system. Those are all service-specific metrics. And if you can get those service-specific metrics, again, you can plot those in graphs, and you can understand if there's spikes or if there's drops, then there could be problems or there could be something else happening in your system. So if you have a huge spike in searches, you could have an API that's making double search requests every time. Okay, if there's a huge drop, you could actually have a network block and your search API cannot talk to your database, or so on and so forth. What we usually measure when we talk about monitoring is number 2, system metrics. I'm sure companies have tools like Nagios or Zabbix or really old style tools that every host checks in, and you get CPU, you get memory, you get whether the host is available, you get whether SSH is open, so on and so forth. Okay? Those are great. Those are wonderful for understanding the health of your host. But they don't tell you the health of your application. And this is where we start to have to get a little bit more involved. There's a really good book on this, okay? And it's by a guy called James Turnbull, and it's called The Art of Monitoring. And over the past, I want to say James first started talking about bad monitoring in 2013. And over the past 3 years, he's actually been writing the book, and it came out last year. I was very privileged to be one of the tech reviewers. And it's a really, really great way of understanding all the different layers that you have to test through your system. Okay, we'll come back to demo, because it's more fun. So where did it come from? Okay, again, I told you this company named Netflix, okay? In 2010, they wrote a blog post called Introducing Chaos Engineering, okay? They have teams of people. It sounds like the best job ever, trying to break your system. That's what they do all day, every day. They have the chaos engineering team. Okay, it's my lifetime ambition to go and work on a team like that. But of course, you have to live in America, and who wants to live in America? Sorry for Americans. So it spawned out of Netflix, okay, and they wrote this blog post, and but what has since come out is that they were actually doing it for 2 years before the blog post happened. Okay, and it wasn't called chaos engineering when they started it in 2008. It was just known as resiliency testing. They were trying to understand the resiliency of their system in production at any one point in time. And out of this came the very amazing Simian Army. Okay, this is a suite of open source tools. If you go to github.com/netflix/Simian Army, you can go and you can play with all of these tools. You can download them, you can use them in your own environment. Just don't toss them into your production environment. Honestly, your boss will hate you. But it's a great way of being able to bring up a little environment locally and test on how you would get to use these tools. And this is the demo that I've shown, or I'm just about to show. Okay, so the main two that people understand and people know are Chaos Monkey. Okay, anyone here know Chaos Monkey? A few people. Okay, a few people. So Chaos Monkey is instance level. It's individual machine, individual container, individual process level chaos. Okay, so you would connect your Chaos Monkey to your AWS account or your whatever account you want, and it will run random commands that you tell it to do in a given time period, and then you can understand what's going on and what's not. Okay, it's very fun. But Netflix took it one step further. They were like, okay, we have regions. If you don't know Amazon's architecture, it's Amazon have regions around the world, okay? So for example, they have a data center in Ireland that's known as EU West 1. They have a data center in Germany known as EU Central 1. They have data center in Oregon known as EU West 2, okay? Those are regions. Within each region, there are a number of there are a number of availability zones. Okay, availability zones you can think of in terms of like they have data centers inside a region. Okay, they have two or more data centers in every region, and you usually, when you use good architecture in Amazon, you would spread your application across all the availability zones in the region, because Amazon usually say that they will not have a region outage, that they will usually have one or maybe two availability zones if there's a problem, but they should never use a third. Of course, that's not always good in practice, because there is a very old data center in Amazon called EU West 1. That's where everything happens. And a few years ago, Netflix were running all of their traffic through EU West 1. Now, in EU West 1, you have the main services like S3, okay, which is their bucket storage or their object storage, and Route 53, which is their DNS. They had a DNS failure, which wiped out the whole region. Do you want me to answer it? So they wiped out the whole region at that point, and anyone who was in that region was having severe difficulties. Like their applications were down, some people lost a lot of data, and so on and so forth. So Netflix were like, hey, maybe we should start to test what happens when we lose a region and seeing if we can fail over. So they introduced this tool called Chaos Kong, which is the big one at the back, and it simulates what happens when they lose an entire region. And they have done it very successfully. So they actually, because of the testing that they did, they were able to fail over from US East 1 to US West 2 and have very minimal downtime, whereas other companies had literally hours, maybe even days of downtime because of loss and everything. So let's go and look at Chaos Monkey. So I spun up a little cluster just before the talk. Okay, it's in US West 2, and I'll explain what it's doing very briefly. Okay, so at the top, this is Terraform, by the way. Terraform is an infrastructure as code tool by HashiCorp. One of the HashiCorp members of staff is at the back, Nick. Go and talk to him about Terraform rather than me. We have providers. Terraform is built into providers, so providers being things like Amazon, Google, VMware, or vSphere, Oracle, Azure, so on and so forth. Think of it as like a cloud, okay? It also has things like DN Simple, or it also has like MySQL, or so on and so forth. It has lots of different plugins. Terraform has lots of plugins that you can choose from. In this case, I'm using AWS. Okay. After that, I'm creating a key pair in AWS. This code is available. You will be able to download it and play with it yourself. Don't run it in your production AWS account because it's not the nicest code in the world, but it works. And at this point, you have an SSH key so that I can SSH into my box. I have a small data source. Ignore that part just because that's a little bit more complicated for normal Terraform. But what that does is that stops me having to go to the AWS console and searching for the Ubuntu 1604 AMI ID. So that's the Amazon image. Okay, so I don't like doing anything by the console. Next, I have a security group that I attach to my instance that allows all inbound and outbound traffic. This is why you should use this in production. You would never really use this type of thing in production, but it's perfect for this type of demo. Can everybody see? Is the black good? Oh, good. Okay, perfect. And excuse me? Better? And after that, we have an instance. An instance in this case, I just call it the chaos instance. Okay? It is of the AMI ID that I got back. It has a type of a T2 micro. It's very small because I'm very cheap and I don't want to pay for it. It has the SSH key so that I can SSH in. I want the public IP address so that I can hit it from the API from the outside. And it has the security group that I want. Okay? Most importantly, it has a tag, okay, called chaos instance. And if I go and I search for tag name, come on, chaos instance. So this is my instance right here. Okay, and it has public IP, and it's a T2 micro, and it's been running since earlier this morning, just because I wanted to make sure that this worked as expected. Okay, so we have an instance right now. Back to Terraform code. When in that instance, there are some manual steps, there are no manual steps that you will have to perform because the code does it for you. What you usually do is you would download, firstly you would install Java, okay, because Chaos Monkey is Java, or the Simian Army is Java. If you're anti-Java, don't worry, it's very easy. The script will do it for you. So it's just a simple matter of installing the Java Oracle 8 JRE. At that point, we clone Chaos Monkey, Gradle build, and then we run Gradle Jetty run, okay? And that actually starts an instance. And I have an instance that I'm SSH'd into, okay? And if I ps aux grep jetty, we can see here, you may not understand what it's doing, but you can see that it's a Java application running Gradle Jetty run, okay? And it sits inside Ubuntu/chaos/Simian Army. So it's actually running the Simian Army right now, and I can actually see it. So let's test that it's actually running as expected. So Chaos Monkey list strategies. Okay. Now this is command line tools. If you're a Mac, you can brew install Chaos Monkey, and it'll just little command line tools that will allow you from your local machine to interface to the API on the Chaos Monkey machine. Okay. For demo purposes, this is perfect. Usually, you would run Chaos Monkey in a cron, or in a schedule, or through an orchestration tool, and it will do those tasks at times you don't expect them to happen. Okay. But for the purposes of the demo, I wanted to actually show you what it's doing and when it's doing it. So we can list the strategies. The ones that are currently loaded for this Chaos Monkey instance is we can shut down the instance, we can block network traffic, we can detach volumes, we can burn the CPU, we can burn the I/O, we can kill processes, and so on and so forth. You can read them all there. And again, all of this code is available, even the commands that you can run and when you run them. Okay, I will post it out afterwards so that you can go and download it and try it. Now, just to show that I've been testing this all morning, okay? So from my local machine on my Mac, I can connect to my Chaos Monkey endpoint, as I told you, because it has a public IP, and it's on port 8080, so it's a simple API that's exposed. I can have a look at all of the tests that I actually ran and when I ran them, okay? And it will give me the result of what it's doing. So in case, instance ID in this auto-scaling group was burned in the CPU, and so on, and so you can read it. So it keeps a history of everything. It actually uses, for its sins, it uses SimpleDB at Amazon. If you know it, it's not very good, but it works for this case, and it works quite well. And it can actually connect to simple email service, and it can actually email you the results. What I've actually done, I have hooked my AWS account up to a trial of Datadog that I opened today, so that you can actually see all of the events that are happening. Okay, and we can see some of them right here. So for example, we terminated this instance, and when that instance was terminated, a new one was launched in its place because of the difference in the auto-scaling groups. So now I can understand what is actually going on in my system. Let's go and have a look at host map. We can see that I have a number of machines spread across availability zones in Amazon. Okay, so I have a cluster. Think of an application cluster. I am going to, let me go back first and show you how that cluster is made. Okay, so the first thing is I build a VPC. So I'm now sort of simulating what my production setup is. Okay, this is now where you'll take advantage of being able to use these scripts. So I want a VPC that sits inside US West 2. So it's my little area of the cloud that I can do as much damage as I want. Okay, that sits across 3 availability zones, and it has 3 private subnets and 3 public subnets. Okay, that's as much of the networking as you need to know. In fact, you can go and you can see that here. We can open the link in the new tab. Does anybody have any idea what I'm talking about? Is anyone lost? Does anyone care? Very good. The fact that one hand went up, that means I don't mind. That's fine with me, I promise. So we can go and we can have a look at our VPC. Here's our VPC. Here's the CIDR blocks. Here's our subnets, private and public. Here's the route tables and so on and so forth. Terraform will do this for you. That module is there. When you download the code, you can play with it and do as you want. No problem. So back to the important stuff. So let's remove that instance. So you can see that I have a number of instances, okay? In this case, I have 19 application instances and 1 chaos instance. The reason I have 19 is about 10 minutes before the talk started, I realized that there was a limit of 20 instances on my account and that my system was continually trying to spin up new instances, so I had to change it all. So there was supposed to be 100, but I forgot to call Amazon this morning, so apologies for that. Inside the account, all I need to do is I have another module. The module in this case is it builds an auto-scaling group, okay, which has a min size and max size. It has a health check type and it has a launch configuration. The launch configuration is as simple as it can possibly be, okay. We have an image ID, we have an instance type, we have security group, and we have a key name. And lastly, we have a security group that goes for this. And all it is just allow in and out on every port. Okay, again, do not use this in production. Please, 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 please. I'm not taking responsibility for breaking your system, although it would be fun. I am available for work. I'm not available for work. And at this point, Terraform plan and Terraform apply will give us an output that looks as much as follows. Okay, and you can see that it's added some resources, but the most important thing is that it has an auto-scaling group name. So the command line tools that I'm using are like a lifesaver, okay? I don't want to have to SSH into a box and run commands within Java to show you what I'm doing. This is a very small interface that you can show people in a demo in your company how this works. So the first one that we're going to try, and you'll have to forgive me. First one that we're going to try is a simple shut down an instance, okay? Now, usually if you don't put in -endpoint, it's going to try and connect to the local Chaos Monkey, okay? So you are putting in a remote endpoint. Next, we're giving it a group name. So that's the auto-scaling group. And lastly, we have a strategy. Remember I showed you the list of strategies that were all enabled for this box, for that Chaos Monkey? You choose one of them and you put it in there. So we hit enter. And it's chosen a random instance. The instance it's chosen ends in 3FB. I can take that instance ID and I can go back to Amazon and I can search it here and we can see it's shutting down. Okay, I haven't even had to go to the Amazon console. So my hypothesis here is that my system is running at a normal state. Okay, an external event comes in and it makes something happen within my system. The external event in this case is a machine shutting down. The hypothesis that I have about my system, because I know my system and I have built it, is that Amazon will replace that instance for me. Okay, because that's how auto-scaling groups works. If you tell Amazon that 19 instances of this application need to be running, Amazon will keep 19 instances running. If one of them is destroyed, Amazon will replace that instance with the same. So when it shuts down, it's currently terminated. And we can see at this point that we have a terminated instance. Now in 30 seconds, just because that's the timeout that I have set, another instance will be spawned by Amazon without me doing anything. In fact, we can go and we can have a watch of what it's doing. Okay, I've made it. There we go. Okay, there's 19 instances. It still believes that 19 instances are in place, but we can go to the instances and we can see one is pending. Okay, it has already spun a new instance in place to replace the one that's just been destroyed. Okay, that's like the most basic Chaos Monkey test that you can do, and I mean literally the most basic. Okay. Of course, make sure that the autoscaling group that you're touching is not something like your primary database server, okay, or your primary cache server, or so on and so forth, because that can have catastrophic problems. And I do mean catastrophic problems. But we can go back to the instances. And we can see at this point there are now 21 instances, which means there are 19 running application instances. And if I do tag name, application instance, we can see that there are 20 there, but one of them is terminated. So this system has come back and it's been rebalanced. Okay, so I have proved that my hypothesis is correct. Okay, great. Let's do something much more interesting. And we can see the history again, because it's stored it in its database, and we can keep all of that for brevity and understanding about what's happened when and what Chaos Monkey has done and how our system is there. One more thing before I do the next demo. If I go back to Datadog and I go to events, we can see right here an instance was terminated and a new one was launched in its place. And if I go into the infrastructure list, the host map, a new one will come up in its place in a second. So it'll place itself back into the host map because Datadog continually tries to find all the new hosts in my system. Okay, so again, only because of the fact that I'm understanding the events in my system and when they happen, I am tracking it because of a tool. Okay, a tool does that for me. So let's go and do a much more interesting demo. So this one's much more complicated. This one is going to say, shut down an instance, as we expect, in this autoscaling group. Count 10 means do this 10 times. Okay? And interval means every 45 seconds. So run this shutdown event sequence of a machine in our instance every 45 seconds. We'll see if it works. Actually, 45 seconds feels like a long time to wait. We're going to pretend that they come up much faster, okay? Because you're not going to want to wait like a lot of time, okay? So we're going to go and we're going to watch the first one, and it shut it down. And the second one should kick in a second. Hopefully, maybe. The second one, very good. Okay, and every 10 seconds, it's going to record a new event. This is much more real-world Chaos Monkey style testing for your system. Okay, and again, if I go back to Amazon in the EC2 console and I refresh, we're going to see all sorts of mayhem. There's 2 boxes shutting down, 3 boxes shutting down. So we're actually simulating that there's a real-world event happening in our system. So out of 19 boxes or 19 hosts, we're shutting down 10 of them in a 90 or a 1 minute and 40 second period. Okay, that shows that there's a problem in our system, and we can probably understand that we're going to have some level of outage at this point. Okay, obviously these boxes have no application on them, just because it wouldn't be very specific to. It would be very specific to my thought process and so on and so forth. But we can start to see that after 30 seconds, Amazon will start replacing these. Hopefully. So there's 2, 3, 4, 5, 6 that are currently shut down. 3, 4, 6, there's 7. So they're continually shutting down. And hopefully we'll start getting some new ones in place soon. Otherwise this is going to look really stupid. And everyone will forget. Shutting down, shutting down. Come on, please. Come on. Our auto-scaling group is going to be going crazy right now. Instances. Our auto-scaling group hasn't even kicked in yet. Oh, there we go, unhealthy. We have lots of unhealthy hosts, and it's going to start replacing them now. So if I refresh, we have almost shut down all of the instances. There you go, all 10 instances are shut down. And Amazon very shortly will start replacing them in place. So this is a much more useful understanding of what's going on. Any questions on that?
What about
What about out of memory? Okay, so out of memories, the question is, what about out of memory problems? Okay, so you can run the same command, and I'll show you. Okay, it may or may not work just because of the fact that each host has got nothing running on it. Okay, so it might come back with a failure in this case, saying a precondition is not met. Okay, but we'll try it. Right, we'll actually try it because I have them. I have the types of commands here. If I go chaos monkey list strategies. And maybe there's no network in place. We'll try burn IO. Okay. So in this case, the strategy would be that your orchestration tool would say burn IO. So it would take a random instance in your system, it would burn the IO of that system, and you would be able to see, with the help of your monitoring tool, which instance, because you can go in at any point and you can see your metrics, your CPU, and so on and so forth. There's no agents, but just to show you that it's there. Okay. So you would hit it, there we go. So it hasn't got the precondition because there's no memory agent installed to say, that the memory is of a specific type. But you would run exactly the same command. And then another one that you would say, burn CPU. And you would have the same thing. Okay, so you have to instrument it. So your system, see what I was saying, that the only precondition to having this in place is actually monitoring so that you understand how it works. And Chaos Monkey will just come back and say, hey, there's nothing I can do with it. Now if I go and have a look at, let me show you what it's doing when I do that. Sudo kill -9. Okay. No, I don't want to do that. Okay, we'll do that. It's fine. No, we won't. PSAX grep jetty. Come on. Oh, here we go. Starting jetty. So here's all of what's going on in there, okay? And we can see it's running. We have the application running at the bottom. But the most important thing is you see when I run that burn CPU command, what it's actually doing at this point is it is saying, come on, okay, it's running the script burn CPU on that specific instance right there. Okay, see it's I06D6A57, so it's still chosen an instance, but that system cannot report back that the CPU is full in the machine. Okay, now the burn CPU script looks as follows. Like if you could see how simple some of these scripts are, you can make them yourself in order to do what? Really? You can't get the GitHub in here? Amazing. Okay. Oh, I can just show you. I think I haven't killed GitHub. Don't be telling anybody I killed GitHub. I really haven't, okay? So at this point, I can just go in and say cd source main resources, scripts. There we go. And if we cat burn CPU, you'll literally see it's as simple as that. It just does a while true of do OpenSSL speed, okay, in order to kill all the CPU of the machine. Okay, it just shows you these scripts are not complicated. They're not difficult to write. They're just designed to cause mayhem in your system. Okay, and that's the most important thing. And of course, because of that, at any point, we can find out what's been run on our system when. We can trace that back to problems within our system so that we can understand where things have gone right or gone wrong. Any questions on that demo before I leave?
Is there a way to make deterministic? So you said it was a test. Can you say, tell me if it's passed or failed?
Is there a way to make it a deterministic test of whether it passes or fails?
If the machines are backed up without you having to know that they're backed up?
Yes and no. Okay, so the first thing is you must have trust. Okay, if you don't have trust, then no. Okay, so in this case, when I destroy instances, I have trust in Amazon that Amazon will bring them back up. Okay, of course, you can have a different API that talks to Amazon that's continually pulling Amazon and say, hey, tell me how many machines are running in my autoscaling group. Okay, and if it drops below a certain amount, it will actually report that it's a fail, and then if it brings it back up, it'll report that it's green. Okay, so it'll do the whole green, red, green thing, and what we would do, the equivalent of like TDD style stuff. So you can make it deterministic, of course. But at the same time, you may or may not want to make it deterministic based on the fact that you shouldn't know when chaos is going to happen in your system. What you should do is not be paged. If you're not paged, there's one of two things happening. One, your system has recovered as expected, or two, you don't actually have your pager switched on, or PagerDuty, or OpsGenie, or whatever. But if you can guarantee that your pages are coming through on time and you don't get paged, then your system is still responding as expected. Okay, so it's all about context. It's all about collecting that information. I think I have like 4 minutes, and I have like 4 more slides, I promise. The code's available for this. I'll tweet it out, okay? The DevTernity hashtag, I'm sure, and also DevTernity will probably try and I'll ask them for a retweet on it. But who practices it, okay? Uber, Dropbox, Google, Amazon, so many companies, okay? These are obviously like some of the bigger companies that do this and like talk about it and go to things. It was the reason Uber do it is that there was a problem when in an outage that they had where their replication logs from their master database to S3 for replication was broken, and their database disk filled up, and they lost their site. They lost how everybody used Uber and so on and so forth. So of course, not a good way. So now they start to inject chaos into their system. Dropbox did it because their master replica pairs in their databases actually stopped talking to each other. Okay, so their sites, when they were talking to a replica, were getting stale data or completely incorrect data based on what the master had. So now they introduce chaos into their system. Google and Amazon have been doing this for years. Okay. I'm not old. I may look 45, I'm not. But there's no need to laugh. Like really, I don't look that old. But seriously, in actual seriousness, I can't really remember when there's been a major outage on Google or Amazon. I know that there has been downtime. Of course there's downtime because there's no such thing as 100% uptime. Anyone who watched Werner Vogel's keynote yesterday at Amazon re:Invent, he said there is no such thing as 100% uptime. You cannot plan for that because it doesn't exist. You plan for 5 nines, and if the closest you get to 5 nines of availability is as close as you can get. Okay, so sites will have downtime, but I can't remember where Amazon or Google have had major downtime in the last few years. I really can't. Now, when I mean major downtime, I mean more than that that 6th nine. Okay, but you look at any major system outage in the past couple of years, and the companies that had those outages are either currently starting to introduce chaos engineering into their system, or they're currently researching the chaos engineering is coming into their system.